I am Pankaj Sharma from Brain League Learning. Welcome everyone. Today we will learn radioactivity for grade 12 NIOS and CBSE students. We'll build an intuitive understanding of what radioactivity is, the types of radiations, how they behave, the law of radioactive decay, half-life, and a quick exam-style example. Let's begin. Radioactivity is the spontaneous disintegration of an unstable atomic nucleus. Inside the nucleus, we have positively charged protons and neutral neutrons crowded together. If the balance of forces is not right, the nucleus can emit radiation and change into a more stable nucleus. Key idea: it is spontaneous, random, and unaffected by ordinary conditions like temperature or pressure. There are three main types of nuclear radiation: alpha, beta, and gamma. Alpha is a helium nucleus, 2 protons and 2 neutrons, heavy and positively charged. Beta is a fast electron, light and negatively charged. Gamma is high-energy electromagnetic radiation, a photon with no charge and no mass. A helpful way to compare alpha, beta, and gamma is their penetration power. Imagine 3 shields: paper, aluminum, and lead. Alpha is stopped by paper. Beta passes paper, but is mostly stopped by a few millimeters of aluminum. Gamma is very penetrating. It needs thick lead to significantly reduce it. Next, how do these radiations behave in an electric field? Between a positive plate and a negative plate, alpha, being positive, deflects toward the negative plate, beta, being negative, deflects toward the positive plate, and gamma, being neutral, goes straight. Now, the law of radioactive decay. The rate of decay is proportional to the number of undecayed nuclei, which we write as dN by dt equals minus lambda n. Solving this gives n of t equals n naught times e to the power minus lambda t. Activity A is lambda times n, so A of t equals a naught e to the power minus lambda t. The half-life, the time for n to reduce to half, is t1 by 2 equals natural log 2 divided by lambda. Let us visualize exponential decay. On this graph, n starts at n naught and falls rapidly at first, then slowly. Watch the dots slide along the curve as time increases. Example time: if the half-life of the sample is 5 days and the initial activity is 800 counts per second, what is the activity after 15 days? 15 days is 3 half-lives, so the activity becomes a naught times 1 by 2 to the power 3. That is 800 divided by 8 equals 100 counts per second. A quick glance at nuclear equations you should recognize. Alpha decay: uranium-238 to thorium-234 plus alpha. Beta decay: carbon-14 to nitrogen-14 plus an electron, and a neutrino which we often omit in basic balancing. Where is radioactivity used, and how do we stay safe? Applications include medical imaging and therapy, radiocarbon dating, smoke detectors, and nuclear power. Safety follows 3 golden rules: minimize time, maximize distance, and use shielding. To summarize, radioactivity is spontaneous nuclear change. Alpha, beta, gamma differ in mass, charge, and penetration. Decay follows n of t equals n naught e power minus lambda t. Half-life equals natural log 2 by lambda. Apply the half-life formula to solve quick questions. Thank you for learning with me. I am Pankaj Sharma from Brain League Learning. All the best for your exams.